I, Professor Avani, Department of Computer Science and Engineering, take it as my esteemed privilege in introducing today's eminent speaker, Dr. Zahid Ansari, Associate Professor, Aligarh Muslim University, Aligarh, who will be delivering a talk on Python for image and video analytics. Dr. Zahid Ansari has 27 years of professional experience in academia and industry. He has 15 years of academic experience, including 13 years as professor, as well as 5 years as dean at PA College of Engineering, Mangalore. Sir has 12 years of industrial and research experience in multinational IT industry, Tata Consultancy Services, and also has engaged in various software development assignments in India and abroad, which includes 6 years in TCS Software R&D Lab at Tata Research Development and Design Center, Pune. 3 years deputed by TCS to GE Harris Railway Electronics, Melbourne, Florida, USA as an IT analyst. 1 year deputed by TCS to United Services Automobile Association, San Antonio, Texas, USA as software consultant. He has published 86 research papers, 47 in international journals and 39 in international and national conferences of repute, and 3 books. Currently supervising 6 PhD research scholars. Number of Google Scholar citations to his publications, citations 314, H index 11, I10 index 12. Reviewer of International Journal of Information Science, Elsevier Publications and International Journal of Fuzzy Computation and Modeling. Indus Science Publications also received Continuous Commitment and Excellence Award in recognition of dedicated service to TCS. Sir has received PhD from Jawaharlal Nehru Technological University, Kakinada, ranked first in 2 PhD level courses at Florida Institute of Technology, Florida, USA, ranked in second in ME Software Systems exam at Birla Institute of Technology and Science, Pilani, obtained first and third ranks respectively in third and final year examinations at Marathwada University. Received second prize among more than 3 lakh students for scoring 98% marks in social sciences at SSC Maharashtra Board examination. He has done 1 year in plant training at Baba Atomic Research Center, Mumbai as a part of Diploma Engineering. Government of Karnataka Vision Group on Science and Technology has awarded funding of rupees 30 lakhs, the VGST research grant for the establishment of Centers of Innovative Science and Engineering Education. Sir bagged the Best Paper category award for the paper A Fuzzy Clustering Based Approach for Mining Usage Profiles from Weblog Data by International Journal of Computer Science and Information Security Technical Committee. He is the lifetime member of Computer Society of India, member of the Society of Digital Information and Wireless Communications, member of International Association of Engineers and member of Association for Computing Machinery. His area of interests include data mining, web usage mining, soft computing, advanced database management systems, model-driven software development, high-performance computing, etc. With this short introduction, I wholeheartedly welcome Dr. Zahid Ansari to this webinar. I request Ansari sir to take over the session. Thank you.
Okay. Thank you, Avani madam. So my today's topic is Python for image and video analytics. And in this, mostly I will be using OpenCV library to do the video and image analytics. At the same time, uh, I will be uh, explaining 2 machine learning techniques knn and k-means with the help of examples. Some very small applications we'll take and we'll do it for that. Okay. So the agenda will start with the Python OpenCV. Installation, I think I'll skip because now I think in recent past, so many conferences in which we have dealt with Python. So you people, I hope that the audience must be knowing how to install the IDE, Integrated Development Environment. So I'll skip in case if it is required by anybody, then that material can be given to them so that we'll save some time. Okay, then we'll start with using OpenCV on Spider IDE. We'll deal with the image processing operations, taking the images, adding the images, image blending, right? Performing bitwise operations on the images, okay? Blurring the image, smoothing the image, thresholding the image, okay? If possible, then image segmentation, age detection, like that. Various operations we'll be dealing with. Simple video handling, how to read the video or how to capture the video using the camera. All those will be seeing. Some of the video analysis also, and machine learning applications using the k nearest neighbor classification and k means algorithm, right? So this is the agenda for today. So Python OpenCV, it stands for Open Source Computer Vision Library. It is created by Intel and maintained by Willow Garage. And if you want to choose the field of computer vision, I mean, you want to work in this field, image processing, video processing, right? The computer vision, then you should have expertise on OpenCV. Your life will become very easy. If you learn OpenCV, then you can develop real-time computer vision application, which mainly focuses on image processing, video capture, analysis, including the features like face detection and object detection. OpenCV is cross-platform, works on Windows, Linux, Mac OS the same way. It is available for various languages, C, C++, and Python. We'll be dealing with Python today. The latest version, what I have seen yesterday, was 4.5.0. Easy to use, easy to install. It supports a number of functions, inbuilt functions, 500 plus, I think, in which you will be getting general image processing functions, image segmentation, transformations, machine learning, detection, recognition, object tracking, feature extraction, geometric descriptors, right? So many things are there. Video related things are also there. So the installation part, I think I will skip. I'll just broadly say that in order to install the Spider, first you need to install Anaconda. So you need to download Anaconda, and it's executable. If you just keep clicking next, it's very easy. You just agree with the licensing, and just it will install it for you. Okay. So if you need the details, that can be given to you later. Once Anaconda is installed, after that, if you type Spider in your search window over there for the application, the Spider icon will appear. Okay. If you double click on this, then it will take you to the Spider. Once you have the Spider, and after that, if you want to install the OpenCV, then either from the Anaconda prompt or from the Spider prompt, there you can type pip install OpenCV Python and it will install OpenCV for you. Okay. There are lots of material available for OpenCV. One of the site is this docs.opencv.org, right? And many textbooks are there. Two of them are over here: Learning OpenCV, Computer Vision with the OpenCV library. This is one of them. Or OpenCV2 Computer Vision Applications Programming Cookbook. These two are the good ones. Okay, there may be others also. So any of these materials can be referred. You can perform lots of image handling things over there, arithmetic operations, GUI drawing, image processing, image analytics, basic video processing, video analytics, machine learning, lot many stuff you can do with OpenCV. Okay. So yeah, these are all the basic operation: reading, displaying image, accessing image properties, extracting RGB value of pixels, extracting region of interest, splitting and merging channels, resizing the image, rotating the image, drawing rectangle on the image, displaying text on the image, right? These are few basic operations. Okay. We'll start with applying the arithmetic operations on the images, how to add the images, how to perform the image blending. Okay. Then we'll deal with the bitwise operations, bitwise ANDing, ORing, XORing, right? Applying the not, bitwise not to the pixel. All this we'll be seeing with example. Then we'll start with the video, how to capture video from a camera, how to play video from a file, how to save a video, all those we'll see. Then how to perform the GUI, drawing lines, rectangles, circle, ellipses, right? Polygon, adding text to the images, all this we will see. Okay. Then how to change the color space. So how to do the colored object tracking with one example. We'll see this. In the geometric transformations, scaling can be performed: translation, rotation, affine transformation, perspective transformation. Okay, some of these we'll see with example. Image thresholding, simple or adaptive thresholding. Then image smoothing or blurring through averaging, Gaussian blurring, median blurring, bilateral filtering. Okay. Then some of the morphological transformations like erosion, dilation, opening, closing, etc. We'll deal with. How to create the histogram, how to plot the histogram, that also we'll see. Then two more operations: the canny age detection, image segmentation with watershed algorithm. Okay. And some of the video analytics we'll do after that. And finally, at the end, we'll be doing the machine learning. Okay. In that, we'll be taking the example of optical character recognition. Okay. Character recognition. We'll see the handwritten digits also, how to recognize the handwritten digits using KNN algorithms. And we'll also see how to recognize the English alphabets using the KNN algorithms. K-means clustering, then also we'll see, and we'll try to apply this K-means clustering for the color quantization. In the images, there are various colors are there, but sometimes the devices, they do not support all those colors. They support only means a limited number of colors. Then in that case, we can cluster the pixels depending on how many colors are available, and so that we can create an approximate image which is very similar to the original image by using a limited number of colors. Okay, so that we'll see. So this is all in front of me for this talk. Let's hope we'll be able to cover all of them. The last part definitely I want to cover. So if required, I may skip in between some parts, but this machine learning part definitely will cover. Okay. Let me start with performing the arithmetic operations on the images. Okay. Okay, let's say I have an image m1.png. I hope that this a spider screen is appearing in front of you.
Yes, sir. Yes.
Okay. So I'll tell you, in order to use the OpenCV, the first step is we have to import. Once we have installed the OpenCV, after that we need to import CV2. Okay. And every time, instead of every time using CV2, right? If you want a simpler of it, so you can create an alias for this CV2 as CV. So import CV2 as CV. Okay. So now this OpenCV library you can use, module you can use with the alias CV. Okay. In order to read an image, the OpenCV provides a method IamRead. Okay. And in that you specify the image file, whatever is there. So I have got the ml.png file. Okay. So that I am reading in a variable image1. Okay. After that, I want to display this particular image. So for that, I am using a method IamShow, and in that I am giving the name of it, so that in a window in which this particular image will be displayed, in the title bar of it, image1 will appear. Okay. And the image which we want to display, that image variable we are specifying over here. Okay. Then we are doing cv.wait key 0. So it will wait till a key is pressed. Okay. After that, we'll destroy the window which got created over there. Okay. So let's do this. Okay. So it displayed the image. This is the image which we have read it. We displayed image 1, and that image 1 got displayed through IamShow. Okay. If I want to know what is the size of this particular image, I can run this command image1 dot size. Okay. So, okay. Image1 dot size. So its the size is total number of pixels in this. Basically, this is the multiplications of its height into width into the number of channels. Since this is the colored image, so there are 3 channels, GBR, right? The green pixels are there, blue pixels are there, red pixels are there, right? Then it's depending on its shape. Let me show you what is the shape of the image. Image1 dot shape. So the shape is 380, comma 308, comma 3. Okay. So basically 380 rows. So its height is 380 pixel. 380 rows are there. Then 308 is the columns. That is the width. Width of the pixels is 308, and 3 is the number of channels, right? So now the total number of pixels over there, they are 380 into 308 into 3, like that. So that comes out to be this 35 3,51,120. Okay. So these many pixels are there. If I want to extract just the height and width, so basically I want to extract the first two of these dimensions, right? So I am taking it this image1 dot shape, right? Colon 2 means up to 2 not including. So basically the 0th dimension and the first dimension. The 0th dimension is height and the first dimension is width. Okay. So height and width we can extract in this. Yes. So if I see h, what is the height? So height is 380, and what is the width? So width is 308. Okay. Yeah. Now, okay. Now let's see, we want to read another image. that is OpenCV logo. Okay, let me read this particular image. Okay, so for this I am calling I am read. Then after that I'll be displaying this image using I am show. Okay, then I'll wait for a key to be pressed, and after that I'll destroy the window. Right, its a size and shape can also be displayed. So I am executing this whole code, and this will open up a window in which OpenCV logo.png will be displayed. So let me first execute it, then I will share that window to you. Okay. So now you see this OpenCV window. So this is another image. Now my objective is to add these two images. The first one which I shown, and the second one this. But in order to add the images, their sizes should be same. So what we'll do is this image 2, which is of bigger size, this will resize as per the size of image 1. Okay. So I will kill this image and I'll resize this image 2, and I'll give the name image 3 to it. Okay. What I'm doing is I'm resizing the image 2. Okay. I'm resizing the image 2, and what I'm giving the size, I am giving the width and height what I have extracted from from image 1. From image 1 I have extracted the height and width h and w. The same I am giving for resizing purpose to image 3. After resizing, I am displaying this image again. Okay, so let me resize and display it. So I am resizing and displaying it. Okay, so the image got displayed. The image looks like this. Earlier it was a bigger image. Now it is of same size as the image 1. Okay, so we got now image 1 and image 3, they are of the same size. Okay, I want to add these two images. I want to add these two images. So I am adding. So this OpenCV is, it has got a function called add, in which you can specify the images which you add. See, remember both the images, they are of the same size, right? So when we add them, their corresponding pixels, they get added. Okay. Now what happens if by adding the corresponding pixels, if intensity becomes more than 255, then in that case, OpenCV, it cuts it to 255. Okay. So that way the two images, they gets added. Okay. So after adding this, now I am trying to display image 1, image 3, and image and the result. Okay. All together, I am trying to display. Yeah, so all the three got displayed. Okay, but I cannot show you all of them together. I am seeing it in front of me, all the images, but that is not visible to you. So I'll only show you the result image. What is the result image after adding these two images? Okay. So see, this is the result of it. You see the first image and some traces of this OpenCV symbol. This is there. So basically the pixel intensities got added to it, and we are getting this kind of result over there. See, we can have the control on how much we want, which image we want to give more importance, or which image the intensity we can give more weight. In order to do this, OpenCV, it provides another function that is called add weighted, and in that you can give weights to these different images. Okay, so if the first image is given 0.7 weight and the second image is given 0.3 weight, then we'll be getting more features from the first images and we'll be getting the less from the second image. Vice versa, if we give more weightage to the second image and less weightage to the first image, then in that case, we'll be getting more features from the second image. Okay, so all these controls you can make. Okay, so let's say we have the same two images, image 1 and image 3, and I am giving, let's say I am giving the 100% weight to image 1. I am giving 100% weight to image 1, and I am giving 0% weight to image 3. Okay, and let's see what happens. I am trying to add it. Okay, 100% weight I am giving to image 1, and 0% weight I am giving to image 2. And if I add it and display it, okay, I am running this command. I am running it, and the output I am displaying to you. See, the output is exactly same as the image 1, because we have given 100% weight to image 1, and we have given 0% weight to image 3. Okay, so in the output only image 1 is appearing. So this kind of control we can do by doing the add weighted stuff. Okay. Yeah. Okay. So I think I'll proceed from here, and we'll be moving to the bitwise operations. Okay. So what are bitwise operations? Bitwise operations, there is bitwise AND operation, bitwise OR operation, bitwise NOT operation, bitwise XOR operation. Okay. So let's say we want to apply the bitwise AND operation. What is bitwise AND operation? We take two images. Okay. So after we do the bitwise ANDing, their corresponding pixels will be ANDed. Okay. Their corresponding pixels will be ANDed. Let's say these are the binary images. They are the binary images. So the pixels, they are having the value 0 or they are having the value 1. They are having the binary values over there. Okay. So if we perform the bitwise ANDing, if the both the pixels they are 1, then only the resultant pixel will have a value 1. Otherwise, the resultant pixel will have a value 0. Okay. So let's take an example. Okay. I will run this example. I am reading two image, bit image 1 and bit image 2 dot png. I am reading these two images. Then I am applying a bitwise AND operation to these two images. Then the result I am getting in dest underscore and I am displaying the result over there. So I am running this code. After that, I will share the first image, the second image, and the resultant image, all of them, after applying the bitwise AND operation. Okay. Do you see this is image 1? If you see on the title bar, the image 1 label is there. This is image 1 over here. Okay. So you see this is a binary image. It is a rectangle. The left half of it is white, and the right half of it is black. Okay. So this kind of image is there. This is image 1. Okay. Uh, After that, I'll show you the second image, the image 2. Okay. Okay. This is the second image. The second image is basically it is fully black, and inside there is one white circle. Okay. So let's see if we perform the ANDing operation between the first image, what I have shown, and this image, then the resultant will be this one. Okay. See, you see this white half circle is there. White half circle. This white half circle is the only part over there where all the pixels, they had the intensity 1 in both the images. That's why that part is coming as bright white, and rest all the pixels, they are black, because there either both or one of the pixel, it has the intensity value 0. That's why it is appearing to black. Okay. So this way, as we perform the AND operation, we can also perform the OR operation. We can also perform the XOR operation. In case of OR operation, basically, if one of the pixel is having the intensity value 1, then it becomes white. That is, in the result, it becomes white. Okay. This is OR. In XOR, if the corresponding pixels they are matching, then the intensity is 0, that is black. And if they are not matching, they are different, then in that case the intensity is 1. And in case of NOT, let's say if I apply NOT to this NOT, then If it is 1, then it becomes 0, and then if it is 0, then it becomes 1. I would like to proceed for the machine learning now. Okay, I hope that there will have more discussion over there. So I'm moving to machine learning. Let's see over there. First we'll go to the KNN algorithm. Okay, so basically, what is KNN algorithm? KNN is K nearest neighbor algorithm. Okay. In this, we have a set of training data points. When a new data point comes, and these data points which are there in the training set, they have their labels. Okay. When a new data point comes, then in that case, we try to find out the nearest neighbors for that particular data points. So let's say we want to find out five nearest neighbors for that particular data point. Once we see all the neighbors, then among the neighbors, we want to know what are their classes or what are their labels. Then whichever label the majority of the neighbors they are having, that becomes the label of the data point which you want to classify. Okay. So what I will do is I will share one uh, image to you to explain the concept of KNN classification. Okay. We have one data point, this black one. Which class it belongs to? Green or brown? Okay. So let me find out five nearest neighbor. So from this black point, we are trying to find out the distances. And we try to find out the 5 points which are the closest to it. So we found five. Out of these, three are green and two are brown. So the majority is green. So basically the label for this particular point is going to be green. Okay. Yeah, this will be repeated again. So I must be green. Okay. Yeah, just check it again. Which class do I belong to? The black one, green or brown? Let me find my five nearest neighbors. K equal to 5. So we are finding the five nearest neighbor over here. Okay. Over here. So out of the five nearest neighbor, okay, the three are the green labels and two are the brown ones. Okay. The majority is green. Okay. So I will make myself as green over here. Okay. So this way. So this is the concept of the K nearest neighbor. Now I will take you to the K nearest neighbor based classification. Okay. Now what we want to do? Our objective is we have a number of handwritten digits. We have 5,000 handwritten digits. Okay. From the digits 0 to 9. Okay. The images are there. So using that, we want to perform the training. And when a new digit is coming, we want to classify it, whether it is 0 or 0 to 9. So first I will show you the data set. Okay. So this is our input data set. We have 5,000 digits. Okay. 500 zeros, 500 ones, 500 twos, 500 threes, like this, up to 9. 500. These are handwritten. People write zero in different way, right? So different zeros are there. Each row it is having 100 zeros over here. So there are 5 such rows for zeros. Similarly, 5 rows are there for ones. So 500, 500, 1000, like that. So from 0 to 9, basically, these are the 5,000 digit images. Each digit, it is a 20 by 20 pixel. Each digit, it is a 20 by 20 pixel. So what we'll do is, we'll take this, we'll extract the rows, and basically we'll cut it into half vertically. The left half will be taking as the image data set, and the right half will be taking as the test data set. Okay. This way we'll be taking. So I am taking you to spider. Let's go through the code over here. See, we want to do this digit classification. For that, we have written this particular code over there. So we want to use the NumPy library of Python, okay, for the array and the matrix usage. So we are importing NumPy as NP. We want to use the OpenCV library, so we are importing CV2 as CV, right? I am reading the digits.png. The data set what I have shown to you, that is digits.png file. Okay. So I am showing you we are reading digits.png as image. I want to convert this image into the grayscale. So for that, I am calling the method cbt color and I am changing the color to color right BGR to gray. We are doing the conversion from the color to gray image. So we are getting the gray image over here. Okay. Okay. Once we have got our gray image, after that, we want to split it into the individual cells. Basically, this image, it is having 5,000 digits. So we want to split it into the 5,000 cells. So what are we doing is, we are first doing the vertical split. Okay, we are doing the vertical split. Okay, there are 50 rows over there, right? So we are splitting it into the 50 rows. Okay, then each row is there, right? That each row we are splitting into the 100 columns. Each row we are splitting into 100 columns. So 50 rows are being split, then each row is split into 100 columns. That way we are getting the cells. So we are getting 5,000 cells over there. Okay. Once we are getting the 5,000 cells, those cells we are converting to the NumPy array. Why we are converting to the NumPy array? They are very efficient for the computations. So we are converting them into the NumPy array. So name of my NumPy array is X. Okay. Once we have done this, after that, I want to basically change it to the training data set and the test data set. Okay. So the training data set, for that, I am telling the column number 0 to 49. I am taking the column 0 to 49, the half of the image. The left half of the image I want to take as the training data set, column 0 to 49, right? Then from column 50 to 99, that I want to take as the test data set. So I am dividing it into the training data set and the test data set. Okay. Once we have got the training data sets and the test data sets, then we want to create the labels for these data sets. Okay. So in order to create the labels for these data sets, basically for training data set, okay, 250 images, they belong to the value 0. Then the next 250 image, they belong to the value 1. Then the next 250 image, they belong to the value 2. So we are making a range from 0 to 9 over there, and repeatedly contiguous 250 images, we are assigning the value 0, 1, 2, 3, like that. So we are generating the labels over here. Okay. So once we have split them to the training and test data set, and we have created their labels, after that, now we are creating the k nearest neighbor model over here. So we are instantiating k nearest neighbor class over there, knn. Okay. Then we are performing the training over there. So we are calling knn.train method over there. We are passing the training data set. We are passing the labels to it. So it is training. Okay. Then after that, once we have generated the model, we want to find out the 5k nearest neighbor. Okay. So based on that, we'll be getting the neighbors and we'll be getting the result. Basically, that in the test data set, for this test data set, for each of the digit in this test data set, we are trying to find out it belongs to which class. Okay. So the result will give us the class which we found out through the k nearest neighbor. In the test level, we are having their actual class. Then we are comparing if the result is same as the test label for each of the value, then we are trying to find out how many things are matching over there. Okay. So the non-zero thing, if the match value is 1, then in that case it is matching. If it is 0, then in that case it is not matching. We are counting the non-zero values. The non-zero values, it will give us the correct matches over there. Using the correct matches, then after that we are trying to find out the accuracy of it. Okay, the correct divided by the total size into 100, that will give us the accuracy. Then we are printing the accuracy of it. Okay, now let me run this. If I run this, so I have run this, so we are getting the accuracy of 91.76%. So what to learn from this? See, our life is very easy over there. Simply we have to read the image, then we need to split the images into the cells. Okay. After that, we are creating the training and test data set. Then we are creating the labels for the training and the test data set. After that, we are instantiating the k nearest neighbor model. We are training by providing the training data sets. Then we predict for the test data sets by calling the method find nearest. That gives us the result. We compare our results against the actual test labels. If the match is found, then basically that is the correct classification. So the correct classification divided by the total number of the objects we classified, that gives us the accuracy, and that we are printing, and it is giving us the result 91.76. Okay, so basically this is quite a good accuracy which we achieved. If you want to increase the accuracy again, then in that case, basically we need to increase the size of our training data set. We can add some more, maybe the training data set we can increase further, and the test data set we can reduce, or we can add some more images into the training data set. So once more things are there with the errors over there in the training data set itself, the final accuracy of the model, that will be better. Okay, so this we did the classification for the digits. Now let's say we want to do the classification for the character. Okay, in order to do the classification for the character, okay, so let's say next we'll do the same thing for English alphabet, but there's a slight change in the data and the feature set. Here, instead of the images, OpenCV provides a data file, later recognition.data, that is available in the OpenCV samples folder. If we open this, then we see that there are 20,000 lines. And each line, it corresponds to a letter. And there are certain features for that particular letter. I will explain it. Basically, our data file is like this. It has 20,000 lines. Let's say the first line, it is corresponds to for the letter K, for a letter K. So let's say for that letter K, there are some 13 features are there. So the way the letter K was written, 13 features are extracted for that letter K. They are written in the form of number after the letter K. So letter K is there. After that, some 13 numeric values are there. Those 13 numeric values, they correspond to various features of the letter K, what is written over there. Okay. Then the next line, let's say letter J is there. Then 13 features for the letter J are there. Then for the letter M, for the letter I. So like that, the 20,000 such letters are there. I mean, K is repeated many times, M is repeated many times. Each line corresponds to one character. So the first value is the letter, and the next 13 values, they are there. It's the features. This is our data file. Okay, so what are we doing is now this is a spider visible now?
Yes, sir. Yes.
Okay, so let me show you this. I am importing the OpenCV and NumPy. After that, I am loading the text file. The name of my text file is letter recognition.data. Okay. The numeric value, I am reading it as the 32-bit floating point number. Okay. My letter recognition.data file, it is comma separated. So delimiter I have set to comma. Okay. After that, the letter K I want to convert to its ASCII value. So I am converting it into the ASCII value. That way I am loading the data. So my data, it has come into the data variable. Okay. So let me perform these operations. Okay. Let me show you what is there in data now over here from this variable data. See, this is the data now. This is data. So basically, this 19 is basically the ASCII value for some character. Okay. And its features are there in rest of the fields over there. Similarly, all these are there. So we have some 20,000 lines are there. We have some 20,000 lines are there, 19,999, right? Starting from zero. We have some 20,000 lines, okay, over here. So this is basically our input data sets. Now we are splitting our data set into two. Vertically, we are splitting, yeah, no, we are taking the first 10,000 as the rows as the training data set, and the next 10,000 we are taking as the test data set. So vertically, we are splitting into two. So in order to get 10,000 rows, 10,000 rows. Okay. Once we did this, so we got the training data set and the test data set. Out of that, the first column that corresponds to the character, so that we are splitting as a response. Okay. And the rest of the columns we are taking as the training data, right? Similarly, from the test data set, the first column, it is our labels, and the remaining columns, they are the test data. So we got the training and test data and their labels over there. Then we are creating an instance of the k nearest neighbor over here. Okay. So then we are training. We are giving the responses also. We are giving the training data sets also over there. So it knows about this. Then by giving the test data set, we are trying to find out their labels. So we are using find nearest method for them, right? In order to classify the test data sets over there. So we get the test data set over there. Okay. Then we want to know how many correct classifications are there. So wherever result is matching with the label, that is the correct classification. So we are getting the count of the correct classification, and through that we are trying to find out the accuracy. Okay. So if we run all this code over here, okay, then see, we are getting the accuracy 93.06% accuracy over there. So this we perform the basically the text classification. Okay. So we did the OCR, optical character recognition, for the digits in the form of images, as well as the letters in the form of text features. We classified them using the k nearest neighbor classification. Okay. Next, I'll explain you the k-means classifications. Okay, the k-means classification. So to show the k-means classification, I will show you one animation first, which will give you an idea about the k-means classification. Okay, so see, in k-means classification, how it is there. We have a number of data points over here. Okay, initially we choose, let's say we want to form the 4 clusters of it. So we choose the we initially we choose 4 points as the cluster centers. Initially we choose 4 points as the cluster centers. Then we find out which are the points which are closest to those cluster centers. The points which are closest to the cluster center, they are assigned to that particular cluster. Okay. So when we do this, okay, After doing this, we get the cluster centers and a set of points which are closer to them. The initial guess may be the approximate. So the initially selected cluster centers, they may not actually be the cluster centers. So they are adjusted by taking the average of all the points in that particular cluster. After adjusting the cluster center, it is possible that certain points which were earlier belong to the old cluster center, that may not be part of this cluster. So they need to be moved to another cluster centers. This way, iteratively the process goes and the clusters are formed over here. Okay, so this is the concept of the k-means clustering. How to use the k-means clustering using Python, that I will show you with the help of one or two examples. We want to apply k-means to clustering, so we need a data set for this. So let's say we are generating the data sets ourselves. Consider we have a set of data with only one feature, that is one dimensional data set. For example, we can take t-shirt based on the height of the people. So height of the people, let's say that is just one of the feature for finding out the sizes of the t-shirt. Okay, the problem is this. There, there are certain categories of t-shirts, and those t-shirts, they are based on the heights. Okay, so basically the t-shirt sizes, they are the classes or they are the labels, and the heights are the one based on which the class is decided. Okay, so let's say we want to generate the one dimensional data sets. So for that, we are using the Python's random libraries rand int function. I want to generate 25 points. Okay, I want to generate 25 points, and the values I want in the range 25 to 100. So based on the sizes of the people, right from the infants or the small kids to the people, one category is who are in the range from 25 centimeters to 100 centimeters. Another range of the sizes is 175 centimeter to 255 centimeters. Okay, so these are the two sizes, two range of the sizes. So we are generating 25 points in the first range and 25 points in the second range. After that, we are combining them into one. Okay, and we are reshipping it into the 50 rows and one column. Okay, so this is our data set. After generating the data set, we are trying to plot a histogram of it. Okay, so let me run this particular code, so it will generate a histogram. So we generated our data set. The histogram is like this. See, the 25 points are these. Okay, their range is from 25 to 100. Okay, then we generated another 25 points. They are in the range from 175 to 255. Okay, so we have got the two groups of data points with one dimension. Okay, now let's apply the k-means algorithm to this. In order to apply the k-means algorithm, we need to specify the termination criteria. Okay, the termination criteria can be based on two things. One is maximum, how many number of iterations you want, or what is your error threshold. Okay, so here we are specifying that we want to terminate based on the error threshold also, and the based on maximum number of iterations also. So we are telling that the maximum number of iterations are 10 and the error threshold is 1. If one of these conditions that comes, then the algorithm should be terminated. Okay, so now we are applying the k-means algorithm over here. So on the OpenCV, we are calling the method k-means. Okay, Z is our data set. Z is our data set where we combine these two sets of 25 points over there. So total 50 points. Z is our data set. Z is our data set. We want two clusters, so I have given two over there. We want the two clusters of it. Our termination criteria is the one which is specified over here. This is the termination criteria which is specified over there. Okay. Then after that, the flags, we are choosing the initial cluster sender randomly. So we are setting the flag to K means random centers. Initial cluster centers, they are chosen randomly. Okay. So by specifying these flags, now we are running this. Okay, let me run this. So we got the centers, we got the labels, and we got the error in the form of the compactness. Now, we are separating all those points which got the label 0, and we are separating all those points which got the label 1. Okay. So set of the points which have the label 0 are A, and the set of points which have got the label 1, they are B. Okay. So I am making this. Now we are plotting this. All the points with the label 0, that we are plotting with the red color. All the points which have the label 1, that we are plotting with the blue color. And the centers we are plotting with the yellow color. So we are using matplotlib to plot this. And let's see how the K-means algorithm has classified them. Okay, so let's see the plot over here. See, it has the correctly classified, it made the two clusters. This is the first cluster. The red colored, they are all in one cluster. And its center is the yellow one. The value is around 50 over here. Okay. Then the second cluster is this with the points which are in blue color. And their center, it is shown with the yellow color. So this we did using the points with one dimension. Okay. Similarly, we can do this using, we can generate the points with the two dimension. So again, I'm using the randint, but this time I'm generating the two-dimensional numbers with two dimensions. Their dimensions are 25 points with two dimensions and 25 points with two dimensions. Okay. The first 25 points, they have the range from 25 to 50. Other ones, they are having the range from 60 to 85, like this. So now we are working with the two-dimensional data points. Okay. Let me execute this code. After executing this code, okay, we got our data set Z. Now we are applying the K-means algorithm on this data set Z, which is two-dimensional data set. Okay. Then again, we have given the number of clusters as 2. So it will classify these data points into two sets. Okay. So after the classification, we are separating all those points, all those points from the test data which got the label 0, and all those points from the test data which got the label 1. Okay. Now when we plot, then using the scatter plot with x and y axis, okay, and we draw it, so we'll be seeing the result of the K-means clustering over there. I will show you the plot. See, these are the two-dimensional data points over there. It has correctly classified over there. These are the blue points with their center shown as yellow. And here, these are the red points with their center as yellow. Okay. Yeah. Now let's apply the K-means algorithm for a problem called the color quantization. What is color quantization? Color quantization is a process of reducing the number of colors in an image. An image may have maybe hundreds of colors, it may be, but the device which is being to use to display it, that may not support those many colors. So what we want is, we want to reduce the number of colors in the image. One reason of reducing can be to reduce the memory size. Another reasons can be sometimes devices may have the limitations such that it can produce only limited number of colors. In those cases, the color quantization, it plays the important. So here we are applying the K-means clustering algorithm for the color quantization. Okay. So when an image is there, for every pixel, for every point in the image, basically there are three features, right? RGB. It's red intensity value, it's a green intensity value, and it's a blue intensity value. So three features are there for every position over there. We need to reshape the image in the array into m by 3 size, where m is the number of pixels and 3 is basically these three features RGB. Okay. So for this, let's say we are taking an image called home.jpg. Okay. I will show you this image first. What is that image? Home.jpg. Okay. Yeah. So here we are reading the home.jpg image over here. Then we are reshaping this image so that it is two-dimensional, and the second dimension, it is having the value 3. Basically, we are reshaping it into m into 3, where m is the number of pixels. So the reshape function of on the image is it basically, if we give the first argument is as -1, then it accordingly adjusts, it keeps the last dimension value as 3, and the rest it adjusts over there. Okay. So we the requirement to apply for the this k-means algorithm is we want the array in the form of m by 3 over here. So we are reshaping the image into this. So once we reshape the image over here, then we are applying the k-means algorithm over here. The number of clusters. Okay, let's say I tell that the number of clusters are 2. The number of clusters are 2, and we are applying the k-means algorithm. We are getting its centers, okay, and then we are reshaping the image back to its original shape, and then we are showing them. Okay, so let me run this, and I'll show you that the image which is the input image, and what is the image after the color quantization after applying the k-means algorithm. Basically, I wanted to show you that if I make two clusters, then how the colored, let's say the n number of colors were there in the images. Now we are getting an output image with only two colors, but still it is quite similar with the original one. If I choose the k equal to 4, then and I apply the k-means clustering algorithm, then I get an image with 4 colors, and it is very close to the original image. Similarly, when I choose the k equal to 8 and I run the k-means algorithm, I get an output image which is of 8 colors, and it's too close with the original image. So I think I'll stop over here because it is becoming very difficult to show the outputs over here. I'll take the questions now.
Okay, so there is one question from the
Okay.
participant. What is the function of reshape with the values -1, 400?
Okay. The value, okay, fine. Basically, say reshape is basically to shape the array. The array can be one dimensional, two dimensional, three dimensional, four dimensional. Okay. So our image was basically, it was a digit image, which was basically 20 by 20 into 3, 20 rows, 20 columns, and 3 for the channel, I mean GBR value. Okay, over there. We want to flatten this image. We want to flatten this image. So basically, we want to make it 20 into 20, 400. We want to convert it into two dimension. We want to convert it into two dimension. So many digits are there. For every digit, we want we want to have, for every digit we want to have the 400 values flattened for the pixels over there. So we are reshaping it. Minus 1 into 400 means for every digit we want to have the 400 pixel values, and minus 1, it will, the library will itself generate, depending on how many digits are there, it will put that particular dimension value over there. So it is basically to reshape the image. Yeah.
Okay, sir. There is one more question. Difference between MATLAB and Spider OpenCV.
MATLAB and okay, MATLAB is basically a lab, right? An application, right? Which has its own programming language. It has very powerful mathematical library, and it supports so many toolboxes. It is commercial. Its GUI is very very good, right? So MATLAB is, and it's very expensive, right? It is a library. Then this Spider is usually IDE for Python, integrated development environment for Python. Spider is one such. Similarly, there are many others are also there. Jupyter is there, PyCharm is there. Okay, there are so many IDs are there. OpenCV is a library. OpenCV is a library which basically in which comes in so many languages like C, C++, and Python. So OpenCV deals only with this computer vision related things, the image processing and the video processing, etc., related with this. While MATLAB, it is a general, right? It can have various kinds of toolbox. It has its own language also for the development and all those. Okay.
Okay, we can wind up here.
Okay.
Thank you, sir.
Okay. Thank you.
I, Professor Avani, on behalf of the Department of CSE, feel privileged to wholeheartedly extend my gratitude for having Dr. Zahid Ansari, Associate Professor, Aligarh Muslim University, Aligarh, as the speaker of today's afternoon session. I am sure the fine-grained theory concept followed by an excellent hands-on session by the eminent speaker would have given all the participants a complete exposure in materializing and understanding even the highly complicated topics in a simplest way. I affirm that participants will have a lot of takeaway from this highly knowledgeable session and help have an exponential leap in their research progress. Thank you for such a wonderful, highly informative session, for the patience and earnest attempt to reach every enthusiastic mind. Thank you, sir.
Thank you, Avan.